Hello learners, this is education online program. I'm here by teacher Rose Hezekiah, and I'm going to present for you a lesson in chemistry for senior 1 and 2. And our topic for today is about chemical equations, and then we will look at balancing chemical equations. What is chemical equation? Chemical equations represent chemical changes by formulas and symbols. That is, they display how chemical changes takes place. So we have chemical equations. Represent chemical changes by symbols and formulas. That is to say, they show how chemical change take place, and they show these changes by using symbols and formulas instead of writing the whole change using words. So chemical changes or a chemical changes are changes that always changes that gives new substances. Chemical changes are changes that gives new substances, and these chemical changes are usually called chemical reactions. Again, we said chemical changes are changes that usually leads to new substances, and simply chemical change can be called chemical reaction. What happened in chemical reaction? Usually we have the starting materials gives us new products. The starting materials gives us new products. And then the starting materials are called reactants, gives us products. So we said chemical changes are changes that gives new substances. And instead of calling it chemical changes, we call it chemical reaction. And in chemical reaction, we have the starting materials is called reactants, and then the final the final substance is given out will be called the products. So a chemical reaction can be simply represented as reactants giving us products. We have reactants giving us products. For example, let us look at an example of a chemical change or chemical reaction. We have a mixture of ion filings, a mixture of ion filings and sulfur is heated to give us hydrogen sulfide. Is heated to give ion 2 sulfide. So, in what equation we can say ion plus sulfur gives us ion 2 sulfide. This is what we call word equation. We display the whole thing using written words. So we have ion plus sulfur gives us ion 2 sulfide. But instead of writing all this long, we can simplify this using chemical equation. So if we are representing the whole reaction using chemical equation, we have ion, the symbol of ion is Fe, plus sulfur S gives us ion 2 sulfide. Gives us ion 2 sulfide. We write it like this. Ion 2 sulfide. So, in chemical equation, we said ion plus sulfur gives us ion 2 sulfide. We say that chemical equation represent chemical changes by symbols and formula. So we have these are symbols, and then this is what? This is formula. This is formula of a compound ion 2 sulfide, and then we have these are the symbols Fe and then S. So this chemical equation is showing us chemical reaction in form of symbols and formula. Then in equation we have the plus sign. This plus sign is indicating that it's an indication that ion reacts with. It is telling us that reacts with. Ion reacts with sulfur. That's why we have ion plus sulfur. And then we have the sign of the arrow. This sign of arrow is telling us that gives. Gives or to give, or we say to give. So we have ion plus sulfur, or we said ion reacts with sulfur to give us ion 2 sulfide. Ion reacts with sulfur to give ion 2 sulfide. So the plus sign is telling us reacts with, that is ion reacts with sulfur, and then the arrow is telling us to give ion 2 sulfide. So the whole thing is represented in form of an equation. Then in the equations, also, when we show chemical equations, we must indicate the state of the reactants and the products. The state of, that is the physical state. We are talking about the physical state. The physical state of substances, of reactants or the reacting substances, and the products. We need to indicate their physical states. So we usually indicate the physical state by using symbols. So, for example, in the reaction of iron plus sulfur to give iron 2 sulfide. So, the physical state of iron is a solid. We write a small s, close inside bracket. Sulfur is also a solid. And then we have iron 2 sulfide is also solid. So the physical state is indicated using symbols written down at the side of both reactants and products, and they are usually enclosed in brackets. So when you see a symbol down near the reactants and the products enclosed in product, this is indicating the physical state of the reactants and then the physical state of the products. So we have different symbols for different states. For example, we have, let us look at this small table. We have state of substances, and then we have the symbol. We have state symbol. That is solid. For solid state, the symbol is S. For liquid, the symbol is small, letter L. And then for gas, the state symbol is G. And then for aqueous solution, the symbol is AQ. So these are state symbols that display the physical states of substances that are reacting, the reactants and the products in a chemical reaction or along a chemical equation. So, for example, we have a reaction of magnesium reacting with oxygen. Reaction between magnesium and oxygen. Example 2. We have reaction between magnesium and oxygen. Let us look at this example. We have magnesium. The symbol is Mg. The state of magnesium is a solid. We have 2 atoms of magnesium plus oxygen. The state is gas. magnesium reacts with oxygen to give 2 moles of magnesium oxide, which is a solid. And then also we have reaction between ion and dilute sulfuric acid. Reaction between ion and dilute sulfuric acid to give iron 2 sulfate, iron 2 sulfate, and hydrogen gas. So if we put this in form of chemical equation, we have reaction between ion, that is Fe, plus dilute sulfuric acid, giving us iron 2 sulfate plus hydrogen gas. So iron is a solid, and then this is aqueous solution, iron 2 sulfate solution, aqueous, and then hydrogen gas. So when writing chemical equations, we must ensure that the chemical equations are balanced. So this is where we come to the point of balancing chemical equations, because if chemical equations are not balanced, the equations will not be correct. So let us see how we balance chemical equations. For us to balance a chemical equation, there are steps that must be followed. So balancing chemical equations simply is the process of making the number of atoms to be equal at both sides of the equation. For example, we have this equation here. Iron plus hydrogen sulfate plus sulfuric acid, giving us iron 2 sulfate plus hydrogen. We must make sure that the number of atoms at the left hand side is the same as the number of atoms at the right hand side. That is, the number of atoms at the reactants must be the same as the products. That is balancing chemical equation. Balancing chemical equations is the process. Balancing chemical equations is the process of making atoms equal at both sides of reactants and products. That is where we must make sure that the number of atoms that reacted is the same as the number that is given out as a product. Then for us to do that, we must confirm that the equation is balanced by counting. We count the number of atoms at both sides. For example, here we have 1 atom of iron at the left hand side, and then we check the number of atoms of iron at the right hand side. So at the left hand side we have 1, at the right hand side also we have 1. Then we come and screen the number of hydrogen atoms that reacted. We have 2 atoms of hydrogen at the left hand side. Also we look at the right hand side, we have 2. Then we look at sulfur. We have 1 sulfur atom at the left hand side, and then also 1. We come to oxygen. We have 4 oxygen atoms at the left hand side, and then we have 4 oxygen atoms at the right hand side. So this equation is balanced. This is a balanced chemical equation. The number of atoms reacting is the same as the number of atoms given out as products. So we have rules for writing chemical equations, or rules for balancing chemical equations. The first thing we do is we write the chemical formula. We write the chemical formula of reactants on the left hand side, and those of the reactants, the products at the right hand side. We have rules for writing chemical equations. So rule number 1 is that you write the formula. 1. Write the formula of reactants at the right hand side. The right hand side. At the left hand side, sorry. The reactants at the left hand side. And the products at the right hand side. So if we come back to this equation, we have these are the reactants at the left hand side, and then we have the products at the right hand side. Then we balance the equation. After writing the formula, step number 2 is we need to balance the equation. And we said balancing an equation means we have to make sure that is the process of making atoms, the number of atoms equal at both sides of the equation. That is the reactants and the products. And then if it is not easy, you can use fractions. You write fraction, and then after that you multiply the denominator through, so that you reduce it to whole numbers. For example, we have calcium reacts with oxygen. Calcium reacting with oxygen. We have calcium reacts with oxygen according to this equation. To give us calcium, we have calcium, symbol Ca, plus oxygen, giving us calcium oxide. The physical state of calcium is solid, oxygen is a gas, calcium oxide is a solid. So, how can we balance this equation? We have calcium plus oxygen giving us calcium oxide. If we want to balance, we look at the reactants first. So we have 1 atom of calcium at the left hand side. Then we need to check also the number of calcium atoms at the right hand side. So here we have 1 calcium atom giving us also one calcium atom. Then we look at the second, oxygen. At the left hand side, we have 2 oxygen atoms. Meanwhile, at the right hand side, we have only 1. So the number of oxygen atoms in this equation is not balanced. Then let us place 2. We start by placing 2. We said we place whole numbers. We have 2. So this 2 means we have 2 atoms of calcium and 2 atoms of oxygen. Therefore, now oxygen, we have 2 oxygen at the left hand side and 2 oxygen at the right hand side. But again, we have 1 calcium at the left hand side, and then we have 2 calcium at the right hand side. So for us to balance calcium, we need to place another also what? 2 at the side of the reactants. So we have 2 calcium, 2 oxygen, giving us 2 calcium oxide. So when we look at this equation now, this equation is balanced. The number of atoms at the reactant side is the same as the number of atoms at the product's side. Let us look at another example. Let us look at another example. We have sodium hydroxide solution, sodium hydroxide solution neutralizes dilute sulfuric acid. Dilute sulfuric acid according to the equation. So we have sodium hydroxide plus sulfuric acid giving us sodium sulfate plus sodium sulfate plus water. We said sodium hydroxide solution neutralizes dilute sulfuric acid according to the equation. We have this is the equation, sodium hydroxide plus sulfuric acid giving us sodium sulfate plus water. Now, let us balance this equation. We have sodium, 1 atom of sodium at the left hand side, and then we have 2 atoms of sodium, which means the sodium atoms is not balanced. Let us start by placing 2 here. Let us start by placing 2. Put 2 here. We have 2 sodium atoms at the left hand side, and then we have 2. We have sulfur, 1 sulfur, 1. We have oxygen atoms. We have 2 plus 4, which is 6, and then at this side we have only 4. Plus this one makes 5. Let us put 2 here to balance the number of oxygen atoms. We have 2, here 4, 6, here 2, here 4, sorry, plus these 2 makes 6. So oxygen is balanced, sodium is balanced. Then we have sulfur, we have 1, 1. We have hydrogen, here we have 2, and then here we have 2, which is 4. So 2 times 2 is what? 4. So this equation is balanced. Then lastly, we look at the decomposition of potassium chlorate. We said potassium chlorate decomposes, that is breakdown, decomposes According to the equation, we have potassium chlorate decomposes to give us potassium chloride plus oxygen, which is gas, and then this one is solid, and then this one is also solid. Then let us look at this equation. We have potassium chloride, 1 potassium, we have 1, chlorine 1, also 1. We have oxygen here 3, and then oxygen here 2. So what we do first is we put 2. Let us put 2. Then we have 2 potassium, and then we put here 2 also. We have put 2 potassium, 2 chlorine, but then the number of oxygen will raise to 6. 2 times 3 is 6, but here only we have 2. Then we put here 3. So this equation is also balanced. We have 2 potassium at the left hand side, and then 2 at the right hand side, 2 chlorine, and then 2 chloride also, and then we have 6 oxygen atoms. So this equation is balanced. My dear learners, we have come to the end of our lesson for today. See you in the next lesson. Bye bye.